Hey, thanks for watching this video. There's more at Embark Online. You can tweet me, and there is the Pie Guy. All right, this is third grade, Module 7, Lesson 20. And in this lesson, students are going to be constructing a bunch of rectangles, kind of like they've always been. But this time, they're going to have a given perimeter. And they're supposed to find all the different rectangles they can create and calculate their areas. So let's get started. Let's do a little bit of background before we move on to the actual problems and the homework. So suppose we wanted to find all the different rectangles that we could draw that have a perimeter of 16 units. Okay, so now what does that mean? Well, let's remember that a rectangle, okay, this is an example of a rectangle, and a rectangle that has a perimeter of 16 units. So we've learned that the perimeter is this length right here plus this width, and then you get that answer, and then you can times by 2 because there's a matching set on the other side. So we can think of this as the perimeter is equal to 2 times the length plus the width. All right, and so what we're saying, when we have a perimeter of 16 units, we're saying that, let's see, I want to get a fatter pen here. Okay, we're saying that this length plus this width has to equal 8, because we know that, let's see, this piece right here, so length plus width has to equal 8, because we know when we add the opposite side, the other L, we have to get 16. So these two guys add together to equal 8, and that means these two guys add together to equal 8, and that's how we're going to get 16. So we have some choices, because how does our L and our W, how can we make these two guys add together to equal 8? Well, one of them is we could do 4 and 4. All right, so I'm going to use an eraser here, and I'm going to swap this and this, and we're going to replace that with a 4 and a 4. So over here on our table, our length and our width, well, we can have a length of 4 and a width of 4, and that works. What else could give us 8 right here? Well, this could be 3 and this could be 5. So we could make this a 3 and we could make this a 5, and that gives us 8 here, and then this would be a 5 and this would be a 3, and that gives us another rectangle that has a perimeter of 16. So 3 and 5. So a length of 3 and a width of 5. Well, what other option could we do right here that would give us 8? Because we need 8, remember? Because this side and this side right here, so these two guys have to add together to equal 8, so that these two guys could add together to equal 8, giving us 16 altogether, because that's our game, is looking at 16, right? So, well, what's another option? Well, we look over here. We got 4 and 4, we got 3 and 5. I can kind of continue a pattern here a little bit, and I can see that if we wanted to continue the pattern, I can make this a 2 and I can make this a 6, because that would give us 2 and a 6, and that would still give us 8 on these two sides, so that would give us 8 on those two sides. Continuing our pattern, we can see that, oh, I could do 1 and 7, because that would make this guy a 1 and this guy a 7. And so here are all of our rectangles that have a perimeter of 16. Now, if I wanted to, I should kind of try and draw them to scale. So if I wanted to, let's see, 4 and 4. So our length of 4 and a width of 4. Length of 4, width of 4. Right there, 4 and 4. And then I could say, well, how about 3 and 5? Well, 3 and 5 makes it a little shorter, a little longer. There's 3 and 5. How about 2 and 6? Well, that makes it even shorter and longer. There's 2 and 6. And then the last one, 1 and 7. Well, that could be even shorter, even longer. So there's 1 and 7. So here are our 4 rectangles that are possible. All right, so that's the idea of this entire lesson, is recognizing a nice systematic way of finding the rectangles that have 16 or have a particular perimeter. And the basic idea is take that 16 and divide it by 2. In this case, we get 8. And that's going to tell you the two sides, what the two sides here, the length and the width, have to add up to, because we know we're going to multiply by 2 to get that actual perimeter. All right. So parents and teachers, it is possible that you may have to watch this portion. So rewind by about 5 minutes to rewatch this whole portion to make sure you understand what the heck I'm talking about. All right. So let's move on. So here, it does say, the directions say cut out the unit squares at the bottom of the page. But the point is, we're supposed to make all the different rectangles that have a perimeter of 10. And that's kind of what we were just talking about. So in this case, if we want a rectangle to have a perimeter of 10, so we know that that's going to be 2 times the length plus the width. And so that tells us that this side, this length, and this width right here, these two guys together have to add up to 5, because we know the other two sides also have to add up to 5 to give us a perimeter of 10. So let's see, what are all the choices that could add together to give us a perimeter of 10. Remember, we're really, I want to leave that as black. We really want to find combinations of length and width that add up to 5. All right. So, well, we can think of 1 and 4. So one rectangle might look like 1 and 4, because that would give us 1 plus 4 is 5. And then you double it over here to get 5, and that's our perimeter of 10. So what's another one? Well, if we're still looking for combinations that equal 5, well, 1 and 4, how about, 2 and 3? So there's a combination that adds up to 5, and then the other side adds up to 5. What's another combination? Well, technically, we could do 3 and 2, but that's the same thing as this rectangle. So really, there's only 2 rectangles that have a perimeter of 10. You have 1 and 4, length and width, and then you have 2 and 3, length and width. We're supposed to find the area. So the area of this guy, remember area? Area is length times width. In this case, it's 1 times 4, which is 4 square units. And then down here, our area is still length times width, which is 2 times 3, which is 6 square units. So there are our 2 rectangles, both with a perimeter of 10, because the 2 sides equal to 5, right? This side plus this side is 5, so the other side is 5, so there's our 10. And then there are 2 areas. All right, this is a bit of a reading mystery. It's all about the reading on this one. So it says, Katie draws a square that has a perimeter of 20. And we're supposed to estimate what that square would look like. So remember, first off, she's drawing a square. So we know that all 4 sides have to be the same. That doesn't exactly look like it, but pretend, all right? Now, because the perimeter is 20, because the perimeter is 20, that tells us automatically that the length plus the width has to equal 10, because the other length plus the width also equals 10. Well, if the length and the width has to equal 10, but it's a square, which means the length and the width are the same, that tells us the length is 5 and the width is 5. And sure enough, plus another 5 and another 5, 5 times 4 gives us 20. So we have our square, and the sides are all 5s. Now the question is, what's the area? Well, remember, that's length times width. That's 5 times 5, which is 25 square units. SQ dot U dot. Then the last one says estimate to draw a different rectangle. So now it says rectangle. It doesn't specifically say square like it did earlier. That still has the same perimeter of 20. So remember, if the perimeter is 20, that tells you in your rectangle that the length plus the width has to equal 10, because the other length plus the width is also 10. And that's how you get a perimeter of 20. So what combination of length and width will add up to 10, have a sum of 10? Oh, geez, there's lots of them. But we could do like 3 and 7. So we could call the length 3 and the width 7. And this would be 7 and this would be 3. And sure enough, there is our perimeter of 20. So estimate to draw a different rectangle. Well, the rectangle is right here. It's 3 by 7. And then the last question is, which shape has the greater area? So, well, we know that the area of this rectangle that we created here, the area is length times width, which is 3 times 7, which is 21 square units. And we're asked, well, which figure has the greater area, the square that we drew or our new rectangle? And in this case, the square has the greater area because 25 is greater than 21. And that wraps up 3rd grade Module 7, Lesson 20, constructing a bunch of rectangles, but this time with a given perimeter.